Hi, welcome to Unit 3, Collecting Data for AP Statistics. This video is going to focus on Topic 3.3, Random Sampling and Data Collection. All right, let's remember what we've talked about so far. The way we collect data influences what we can and cannot say about that population, which is why how we collect data is so important. When a sample is selected from a larger population, the number one thing is it must be selected randomly in some way. Now, when we talk about selecting data from a group, we have to think about two things. Is it sampled without replacement or with replacement? So what does without replacement mean? Well, when an item or person from a population can be selected only once, this is called sampling without replacement. Imagine picking out names on slips of paper cut out of a hat. And once a name is picked, you do not place it back. This is typically how sampling is done because you don't want to pick the same person or item twice. This does change the probability of a person being picked each time. Now, I want to prove that to you because for some people that could be a little bit confusing. Now, what I mean by that is imagine that there are 20 names in a hat. That means that on the first pull, each individual person has a 1 out of 20 chance of being picked. But now, because that person was picked, there's only 19 names left in the hat, and now everybody left has a 1 out of 19 chance of being, of being picked. And then there's a 1 out of 18 chance of being picked. And then there's a 1 out of 17 chance of being picked as people are picked out. So the probability is changing for each person as it goes on, but the most important thing is I can't get the same person twice. Now, the opposite of that is sampling with replacement. When an item or person from the population can be selected more than once, this is called sampling with replacement. Imagine picking names written on slips of paper out of a hat, and after a name is picked, you put it back into the hat. So if Sally gets picked, her name goes back into the hat, she could be picked again. Now, the one thing this does ensure is that the probability of any name being picked stays the same all the time. Every time you reach in, there's a 1 out of 20 chance of your name getting picked from that hat because we're replacing the name. Now, again, that's not really typically how it's done because, like, if we're trying to get a sample, we don't want Sally 15 times. We want 15 different people. So that is why we typically do sample without replacement. All right, now, what we're going to learn in this video are 5 different ways to sample data well. And I want to make sure that we understand those ways. So I'm going to start off with giving us those 5 ways in an example. And then we will specifically talk about each of these and what is the actual name of that technique. So imagine if we have 28 swim park hotels in Ohio. So these are Ohio, hotels that have like swim parks inside of them, right? Water hotels or water park hotels, whatever you want to call them. And we want to get a sample of them. Maybe we want to see out how many average rides they have. What's the average cost per night? What's the average cost of a room? What's the average amount of people that visit there? Maybe we want to find out the proportion of people that are from out of state versus in state. I don't know. The point is I want to collect some data from these hotels, right? So I want to select 5 of them. And here's a couple different ways I could do it. One is I could just pick all the names in a hat, and I could pick out any 4. Actually, I don't realize why I have 4 versus 5. Whatever. Sorry about that little bit of a typo there. But I got all these names of hotels in a hat, and I pick them out to get my 4 or 5 hotels, however many I want. Imagine that another way we do it is we separate the hotels by their rankings. Hotels usually have rankings like a 1-star, 2-star, 3-star, 4-star. Like a 4-star hotel is it's a really nice hotel. So maybe I first separate the hotels by their rankings, and then I pick 1 hotel from each group, and that ends up being my sample. That's another way that I could do it randomly. The positive there would be that I would have 1 of each type of hotel, good all the way down to bad. Divide up the hotels by where they are located. So maybe there are 28 hotels all across Ohio, and I'm going to break them up to where they're located, northeast, northwest, southeast, and southwest. And I'm just going to pick 1 of those locations, and I will visit every swim park hotel in that region, right? So if the northwest gets picked, any of the hotels that are in that region will get picked. Now, maybe I end up with more than 5 because there's more than 5 hotels in that region, but that's the method I used. Maybe another option is I can create an alphabetical list of the hotels, and I'm going to select a random starting point. And from that random starting point, I will select every 5th hotel on that list. And one last thing I could do is just take a sample of all 28 hotels. That would be called a census. So instead of picking a couple of the hotels, I just look at all of them. Now, the most important thing is 5, I look at all the hotels, but 1 through 4, where I'm sampling, there is a little bit of randomness into every one of those. And that is really, really important. All right, so the names of these 5 different techniques that I just gave you an example of are 1, simple random sample, which we abbreviate as SRS. 2, stratified random sample. 3, a cluster random sample. And 4, a systematic random sample. And finally, 5 is a census. Now, the 1, 2, 3, 4, 5 from the examples I just gave you do correspond with the types that I'm listing. But now what I want to do is actually talk more specifically about each one of these types. That way you could better understand it. All right, a simple random sample is exactly what it says. It's very simple. It's a sample in which every group of a given size has an equal chance of being selected. So if I'm going to select 4 hotels, any group of 4 hotels could be picked. All 4 hotels picked could be from the Northwest. All 4 could be from the Southwest. There could be 1 from each. All 4 could be 1-star hotels. Wah, wah, wah. All 4 hotels could be on the same street in a certain city. Who knows? I mean, that would be weird, but that's the point, is any sample of size 4 could be picked. The key here, a lot of kids misread this, and they think that a simple random sample says each hotel has a chance to be picked. No, it's each group of size 4 or 5, however many you're picking, has to have an equal chance. Let's do another example so you can really understand this. Imagine I want to select 40 students from a high school that has 1,500 kids. All right. Any group of 40 needs to have a chance to be picked. I could get all 40 males. Now, that would probably be pretty weird if I did it randomly, but that could happen. I could get all 40 seniors. That would be kind of weird, but it has to have a chance to happen. You would think if it's truly random, those 40 students picked would be a nice mix. You would think, or we would hope so, right? Now, what are the different ways that you could go about collecting a simple random sample? Well, there's actually 3 that we accept in this class. Number 1 is give each individual a unique number. So every person in the population gets a unique number. Then we use a random number generator to select which ones to include in the sample. Now, a random number generator is usually a computer or a calculator. Actually, our calculators have a random number generator, and it literally just generates random numbers. So once everybody has a unique number, you would use a computer to generate a number. You'd be like, all right, 46, person 46, you're picked. And then person 82, you're picked. You do need to ignore repeats because it's not like they sample without with replacement, right? If 56 gets picked, 56 might get picked again. So you just ignore repeats because you don't want the same person picked twice, and numbers that nobody has. Like, a random number generator might make a random number like 1,342. Well, if nobody has that number, then don't pick it. The second option to attain a truly simple random sample is to give each individual a unique number. So same starting point. And then we're going to use what's called a random number table to select which ones to include in the sample. Now, a random number table is kind of like a random number generator. It's just not computer-based. It's literally a piece of paper with a bunch of random numbers on it, and you just start picking numbers off that piece of paper, and whoever's numbers gets picked are the people that participate in your sample. Once again, you could pick the same number twice, so we got to make sure to ignore repeats, and we also have to make sure to, once again, ignore numbers that nobody has. The third thing you could do is kind of like the more elementary-ish, or something that, most kids would come up with. I, had to ask them on their own how to do this. They would just say, well, let's put everybody's name on a piece of paper, put those pieces of paper into a hat or a bowl, mix it up, and then choose it out without replacement, right? So if Dawn gets picked, I don't want to pick Dawn again. And then if Rebecca gets picked, I don't want to pick Rebecca again. So that would need to be done without replacement. Now, the randomness there comes in the fact that if you mix the bowl up, it should be completely random what you pick. I mean, obviously, we don't want to look into the bowl. We want to make sure we're blindfolded or something silly like that. But those are all 3 ways to collect a simple random sample. I do want to quickly show you what a random number table is. It's like I said, it's literally a piece of paper with random numbers. So what you would do on a random number table like this is you would just, you could start anywhere you want. I'm just going to start on this row right here. So you would say, all right, person 84, can you please come on up? Person 18, can you please come on up? Person 09, can you please come on up? You literally skip the gaps. The gaps are there just to kind of make it look a little neater. Sorry, so again, pick anywhere you want. So 40, 79, 19. Now, if we were choosing our high school students, now remember, we had 1,500 high school students. So that means some people are going to have 4-digit numbers. So I would have to choose 4-digit numbers. So 3931. Now, nobody has that number because there's not that many kids, so I would skip it, right? 7817, skip it. 0661. Now, that would be a 4-digit number, and person 0661 does exist. They would get picked. So that is how you could use a random number table to pick your people. The pros of a simple random sample are that it is truly random. Think about the fact that any sample of size n could get picked. If you think about a sample, even weird samples like all boys, that would be strange, but because it's truly random, that sample could be picked. It is fairly simple to do, and there's not a ton of planning that has to go into it. But sometimes when your population is really big, it takes a long time to give everybody a number. That's the only point that could kind of stink. So that's one of the cons. If the population is really large, this could take you a long time to actually do. Another con is that it potentially could not represent your population. If your population is very diverse, like there's boys, girls, old people, young people, healthy people, unhealthy people, well, you could, because any sample has a chance, you could get a weird sample that doesn't truly reflect your population. Now again, we don't really worry about that with simple random samples because it is very unlikely for that to happen. If it's truly random, you should get a nice mixed up sample, but you just never know. So I do have that listed as, a con. So that's a simple random sample. It is very simple. Everybody gets a number and you just start picking people to be in your sample. All right, the second type of sample we could do is called a stratified sample. Now, a stratified random sample involves dividing up the population into separate groups first. So before we do any sampling, we divide up the population into groups called stratas. Now, we decide who goes into which group based on a shared attribute or characteristic. We call this homogeneous grouping. A very simple way of doing this, a very, very rudimentary way of doing this, would be boys and girls. So all the boys go into a group, all the girls go into a group. Very, very simple. If you're working with something that is racially, where that would be important, or you want some diversity in terms of race, you could separate by ethnicity, whites, African Americans, Asians, Pacific Islanders, and so forth. Then, once you have these stratas, these homogeneous groupings, you then go to each group and you perform a simple random sample. So you'd go to the boys and you would do a simple random sample where everybody gets a number and you randomly pick 10 numbers. And those 10 boys are in your sample. And then you go to the girl group, everybody gets a number, and you randomly pick 10 girls to be in your sample as well. So then the combined groups from both stratas, right? The boys that I picked, the girls that I picked, put them together, and that becomes my sample. So it basically, if I want to draw a picture of this, right? You create groups, and the people in each group are similar for a reason, right? Like you want it to apply to what you're asking, right? Like if gender has nothing to do with the question you're asking for your sample, then find another reason to do this, right? So you create these groups, and you can have a ton of groups if you want, doesn't matter. And then you do a simple random sample in each group. So you take a couple people from each group, randomly, of course, and then the combinedness of all those people picked become your sample. All right, a couple more comments on stratified. The stratas do not have to be equal in size. If you have 100 boys and only 50 girls, well, then so be it. But create them based on something that matters, right? Like this is what I was trying to say earlier. If gender doesn't matter at all to you, like you don't think it's something that matters, then don't do it. If you're doing it, some type of sampling and the question you're going to ask deals with how they style their hair or the new shampoo and how a shampoo affects their hair or how long they shampoo for, whatever. If it does with hair, then it would make sense to create groups based on hair color. So maybe you have a group of people with brown hair, a group of people with black hair, a group of people with blonde hair, and then you take a couple people from each group. And the good thing here is what this is going to do is it's going to give you a nice representative group. It's going to guarantee you a couple different hair colors, right? Keep in mind that we do want to create our stratas based on something that they have in common, one or more characteristic. Like you could do groups of boys with brown hair, another group of girls with brown hair. A different amount of individuals can be selected from each strata. Meaning if one strata is much larger than another, feel free to take more people from that group. Like you don't have to take 5 from every group. If there are double the boys, well then take more boys to be in your sample. But you just don't forget, you also still have to go to that girl group and take some girls. So an easy example to explain a stratified random sample to you would be to look at my 100 or 1,500 students in high school, and maybe I'm going to break them up by grade, right? That would probably make a ton of sense, right? So I'm going to break them up by freshmen, sophomores, juniors, and seniors, because, when you ask kids questions, their age matters. Seniors have a lot different things going on than freshmen. So I'm going to break them up by that. And maybe there's a different amount of kids in each group. I mean, who cares? But the point is I'm going to visit each group individually. Everybody gets a number, pick maybe 10 kids from each group. And those 40 total kids, freshmen, sophomores, juniors, seniors, become my overall group. When I was doing my hotel example, this would be breaking them up by their label, 1-star, 2-star, 3-star, 4-star. So that was the stratas I created based on something they had in common. I took all the good hotels went together, all the bad hotels went together, and then I wanted to get a nice mix, so I took a couple hotels from each of those ranking categories. Now, what are the pros here? Well, if your population is very diverse, this will guarantee you a very representative sample. So the great thing about Stratified is because you're purposely taking a couple people from each group, it gives you this really nice representative sample. It will ensure the population is well represented. Now, some cons of this is first, it can be very, very time consuming. You have to go to each group. If you have 5 groups, you have to essentially do a simple random sample 5 times. You got to give out numbers to everybody in the girl group. Then you got to give out numbers to everybody in the boy group. And then you got to get some numbers to pick. I mean, it does take a large amount of time. Another con is that it's not a simple random sample. And I'm not trying to rank these, like none of them are better than others. They're all just different ways to sample. But what I want to mention here is that when you purposely take a couple people from each group, it no longer becomes simple random sample overall, right? Because imagine, one of the definitions of a simple random sample is that any group is possible. For example, you could get all 40 boys. Well, if I purposely take 10 girls and 10 boys, then obviously I can no longer ever get all boys. So that is what makes Stratified different than simple random sample. All right, the third technique is called a cluster random sample. A cluster sample involves dividing up the population into smaller groups called clusters. So it kind of sounds like Stratified to start, but we call the groups clusters. Now, ideally, there is heterogeneity within each cluster, meaning that within each within each cluster, there is a huge, real nice mix of people. And clusters are similar to one another in their composition. So this is a little bit tricky to explain, but in simple terms, each cluster is a nice mix of the population. So remember, in Stratified, we made groups that were very similar within, very different between. With the cluster sampling, we do the opposite. We make groups that are very different within, which means they're very similar between. So let me kind of draw you a picture to explain this. So what we have is we have these clusters, and each cluster is very similar in the sense that each cluster is different. So maybe this cluster has boys and girls and African Americans and white people and Asians and Hispanics, and so does this group, and so does this group, and so does this group, and so does this group. So each group is very different within, which means that they are very similar between. So this is very opposite of Stratified. Then, here's the kicker, I think you're going to like this, then we label each group, 1, 2, 3, 4, 5, and we randomly select one cluster to become our entire sample. So why is this a good thing? Well, because each group is already a nice mix, when I select, say, group 3 to be my sample, I'm getting a nice group already. So the example I did with this with my hotels is, remember when we divided the hotels up by direction. So we had northeast, northwest, southwest, southeast. Now I'm assuming in each region I'm going to have some hotels, and I'm going to have some good hotels in each region. I'm going to have some bad hotels, big hotels, small hotels. Each region is going to have a nice mix of hotels. So if I randomly pick this region and visit every hotel in that region, I should get a nice mix of all different kinds of hotels. It still was random, so any group could have been picked, but that was the group that got picked. And we're going to talk about the cons and pros of this, but the biggest pro is that it's a lot easier to do, because no longer do I have to number every single person in the groups. I just number the groups and just pick one of the groups, or heck, I could pick 2 groups if I want more people to become my entire sample. So here, let's keep in mind the population is broken down to groups, where the groups are, in a sense, mini representations of the populations. Like, I would assume that the hotels in the Southwest are a mini representation, meaning that there's 1 star, 2 stars, 3 stars, 4 stars, big hotels, small hotels, a nice mix. So any cluster that gets picked would therefore represent the population well. So it's perhaps best used when the population is fairly undiverse. So we're going to do an example later that talks about that. But it's used when the clusters are naturally occurring or pre-made as well. So like, if your groups, or if your population is already divided up, that's where a cluster could be really good. So when I did the directions of Ohio, right, north and south, east, west, and so forth, when I broke it up like that, that was like pre-made. Like, I didn't make those groups. Those were just the directions of, directions. So the point was that since I thought that those 4 groups pre-made for me were already nice mini populations, then picking one of them at random would make a really good sample. So here's an example of this with my students. So imagine I got my 1,500 kids. Now, imagine the 4 lunches at a school. Like, say a school has A lunch, B lunch, C lunch, and D lunch. If you think about it, each lunch is a nice mix of kids. Each lunch is going to have boys and girls, sophomores, freshmen, juniors, seniors, rich kids, poor kids, kids that buy lunch, kids that don't buy lunch, kids that get good grades, kids that get bad grades. Each lunch is like a pre-made, beautiful representation of the population. So what I then do is, instead of labeling the kids, I just label the lunches, and I maybe randomly pick lunch A to become my entire sample. Now, if my goal was 40 kids, I might end up with more, but that's a good thing. Why would that be a bad thing if you had more kids? So that's the idea of a cluster sample. The pros, it's so much faster and easier because you don't have to label the individuals, you just label the groups. You don't have to number all the individuals, which is what I just said, sorry. And also, again, because the clusters are already nice mixes, they should be representative, which is always a good thing. Now, the cons is that you do have to create the clusters, which could take time. That is why I think it's best to use this method if you have kind of pre-made clusters that you don't have to really do any work to create. If the population is very widely diverse, this could not work out. Like, if your population is very, very, very diverse, then this could not be the best method to use, right? And we'll talk about that. So, right now, all these methods, I hope, are going to, help you a lot, and you're going to learn them. But at the same time, we have to look at a lot of examples for you to truly understand all of them. All right, let's look at the next method here, the systematic random sample. This is where we literally just pick a random starting point from some type of list, and then we have an interval that we pick from. So the easiest way to talk about this is like select every 10th person from a list where we choose a random starting point. So like if I put all those hotels in a random list, or even if an alphabetical list, that doesn't matter. As long as you choose a random starting point, and then from that starting point, you're going to select every 6th hotel or every 10th hotel, whatever, it doesn't matter, but that's systematic. The good thing here is that you could just use a list. You don't actually have to have the individuals in front of you. You could just have a list, and you could go from that list. So that's kind of a really easy one. It is random, and it's easy. So a lot of people like systematic random samples because of that reason. And lastly, we have a census. A census is where you literally sample everybody in the population. Now, this is only possible if your population is remotely small. If a population is very large, a census is extremely time-consuming and very expensive to do. I would never, ever recommend a census if your population is big. I mean, if you're at a very small high school in North Dakota that only has 50 kids in the entire high school, well, by all means, do a census. It's going to be very, very easy. But I would never do a census for a large population. Way too expensive and time-consuming. Now, I do want to just give you a quick warning. Know and understand that there are advantages and disadvantages to each method. All 5 methods are good. All 5 methods are random, but sometimes it's better to use one than another depending on the situation. And on top of that, some scenarios will naturally lead themselves to a better method. So really take the time to think, who is your population? What variables within that population could impact what you're going to ask? And you got to take all that into account before you actually go ahead and do the sample or pick what you're going to do. All right, so let's go ahead and do a quick example here and just kind of walk through all 5 very quickly. All right, I got 100 boxes. Each box contains 50 toys of the same toy. So I basically got 50 times 100. I got 5,000 toys. And they're all the same toy, right? So this is a very undiverse population. They're all the same toy. So a simple random sample, every single toy would have to get a unique number. I could go 0, 0, 0, 1 all the way through 5,000. I would then have to use a computer, a table, or put all the numbers in a hat and then choose, let's just say 25, whatever your sample size is. It's completely up to you how many you want to pick in your sample. But that would be how you do a simple random sample. Stratified. Well, my thought here is I got 100 boxes. Why don't I just go to each box and take one toy out of each box? Wow, that's stratified. I already have boxes. The boxes are already grouped together. All the toys in that box are the same toy. So I'm going to go ahead and just pick one toy from each box. That's the key thing from Stratified, is from each box. The only downfall there is I got to label all the toys in each box, use my random number table or use my random number generator to pick one toy from each box. That could take a long time. Cluster sample. Okay, well, once again, I already got 100 boxes. Each box is already a nice mix of toys. They're all the same toy anyway. And their boxes are pre-made. So why don't I do this? Why don't I label the boxes? Don't label the toys. Label the boxes 0, 0, 1 through 100, or you could do 0, 0 through 99, whatever. And then pick one box. And that one box that gets picked becomes my entire sample. All 50 toys in that one box become my sample. I mean, they're all the same toy anyway, so that would be a great idea. That's going to be so much faster for me to do. Systematic would be, I'd have to unbox every single box and get a long list of every single toy. I would not want to do systematic here. And then maybe I pick every 5th toy. Well, that's just, I gotta take all the toys out of the boxes. That's going to take too much long. A census is where I would literally select every single toy and measure every single toy for quality. I don't have time to look at 5,000 toys. That's going to take way too long. All right, and let's look at one more quick example here. Here are my 28 swim parks. I actually went ahead and found the names of the 28 swim parks in Ohio, and let's select 4 of them. And now I gave them numbers already, 0, 1 through 28. So simple random sample would be to use some type of computer to generate 4 numbers. Ignore repeats, ignore numbers that nobody has. And once 4 different hotels get picked, there's my simple random sample. Stratified is maybe I just group them off. For example, maybe these are my 1-star hotels. These are my 2-star hotels. These are my 3-star hotels. And these are my 4-star hotels. Okay, so then I'm going to I'm going to go to each group and I'm going to pick one hotel from each group. So I am going to have to go separately to each group and pick one hotel from each. That would be stratified. Cluster could be if, instead of these being my stars, let's just say these were my hotels in the Northeast, Southeast, Northwest, Southwest. Now that's just convenient for me, right? They're already, that's where they are. I don't have to do any work to put them in groups. Those are their groups. And then I'm going to label the groups 1, 2, 3, 4, and then one group becomes my entire sample. Systematic would just be picking a random starting point, like maybe Radisson, And then every 5th hotel, 1, 2, 3, 4, 5, sea grape, 1, 2, 3, 4, 5, tropical breeze, and so forth. And a census would be, again, going to every single hotel, which I don't have time for, so I wouldn't do. All right, that's it for this video. I know it was a very long one, but there's a lot of key details here. So hopefully it all makes sense to you guys. And you might have to watch this one in parts. I apologize. It was kind of long. All right, see you in the next video.